Hello guys, welcome to today's class. In today's tutorial, I'm going to teach you multi-threading concept in Java. So in this tutorial, I'm going to teach you Java multi-threading in detail with a lot of example program. So I recommend you to watch this video till the end for the better understanding of multi-threading in Java. First thing first, what is multi-threading? Multi-threading refers to a process of executing two or more threads simultaneously for the maximum utilization of CPU. In operating system, I'm sure that we know, if you want to run a process, it has to be resides on the main memory. So in order to run more than one process simultaneously, we use the concept of multi-threading. Here, a thread is a lightweight sub-process or the smallest unit of processing. So before we learn more about multi-threading and how to create the thread, let us learn the lifecycle method of a thread. Lifecycle of a thread in Java is basically state transition of a thread that starts from its birth and ends on its death. So basically this lifecycle method have 5 stages. First one is a new or newborn state. Second one is a runnable. Third one is a running state. Fourth one is the blocked state, and fifth one is a dead state. As you can see them here in this example diagram, that depicts the basic life cycle methods of a thread. Let me explain each of these states in detail so that you will understand what is this stage new in the process of creating a thread. New or newborn state, when we create a thread object using a thread class, thread is born and it is known as to be a newborn state. That is, when a thread is born, it enters into a new state, but the start method has not been called yet on that particular instance. In case if you don't understand how to create the object for the thread class and what does that mean, the start method, don't worry, I'm going to give you an example program. By then you will understand what is that start method, how to start the thread. So basically this is the diagram that explains a newborn state in thread. So here is the newborn state. Here this thread will not enter into the runnable state unless I call the start method. If I call this particular thread with the start method, then it will enter into the runnable state. So what is runnable state? I will explain you in the next slide. So in case if I don't call this thread class with a start method, I can call this thread class with a stop method. What does that mean? If I stop that particular thread, it will go straight into the dead state. So basically dead state is nothing but the thread after the execution. Thread means a sub process. The second state is a runnable state. So what is runnable state? Runnable state means a thread is ready for the execution. For that, when the start method is called on a new thread, then thread will enter into the runnable state. So initially the thread is created, we call that one as a newborn thread. Then from there we are going to use the start method so that that particular newly created thread will enter into the running thread or runnable state. So for example, it's not necessarily is going to be the running state. When you call the start method, actually it will reach the runnable state. Runnable state is the state before the running state. For example, let's say I have created 3 threads and then I have called those 3 threads. Basically those 3 threads will reach the runnable state. As you can see them here in this diagram, there are 3 threads have called with the start method. Now they are queued up in the runnable state before it enters into the running state. Then what is running state? Running means, here you can see, running means a processor has allocated the time slot to the thread for its execution. When the thread scheduler selects a thread from a runnable state for execution, it goes into the running state. Look at this figure. In running state, processor gives its time to the thread for execution and executes its run method. So this is the state where thread performs its actual functions. A thread can come into running state only from the runnable state, as I said. A running thread may give up its control in any one of the following situations, and it can enter into the blocked state. So let us just quickly look into this diagram. When this sleep method is invoked, a thread to sleep for a specified time period. The thread is out of the queue during this period of time. Then the thread again re-enters into the runnable state as soon as this time period is elapsed. So for example, there is a thread that reaches to the runnable state, then from here it reaches the running state. For some reasons, that thread is not executed within the given time slot. So in that case, that process will take the sleep mode. So what does that mean? For a certain amount of time, that particular thread will be in sleeping mode. Then after that time elapses, it will again enter into the runnable state. It won't straight go to the running state. Instead, it will come and queue up in the runnable state after that time has elapsed from that sleep method. So for example, when a thread is suspended using the suspend method, as you can see them here, there is a method name called suspend. Let's say the thread has suspended using the suspend method for some time in order to satisfy some particular condition. Basically, a suspended thread can be revived by using resume method. As you can see them here, maybe this particular thread has been suspended for some reasons, but again if you want to revive this thread that has been suspended using this suspend method, a resume method can be used in order to revive the suspended method. In that case, again, instead of going straight into the running thread, it will reach the runnable state. It won't go straight into the running thread. Instead, it will come and queue up in the runnable state until that time comes for that particular thread. Then, when the wait method is called on a thread to wait for some time. So, apart from this sleep method and then suspend method, there is a method name called wait. What is that wait? When the wait method is called on a thread to wait for some time, the thread in wait state can be run again using notify or notify all method. For this notify and notify all method together with the wait method, how does that thread works? We will see them in an example program so that you will understand how the wait method work on the thread and how to work with the notify and notify all method. Then the fourth method here is as you can see them here, blocked state. So what is blocked state? A thread is considered to be in the blocked state when it is suspended or sleeping or waiting for some time in order to satisfy some condition. So when you say a thread is in this blocked state, maybe it can be there for the following reasons. Maybe the thread has gone for the sleep mode, or the thread has been suspended, or maybe the thread is in the wait. So these are all the instances where a thread can go into the blocked state. Finally, dead state. As you can see them here, dead state. This is a fifth level of life cycle method of a thread. So what is dead state? A thread dies or moves into the dead state automatically when its run method completes the execution of statement. When the thread has executed, let's say here when you reach this level, the thread has already executed. In that case, it will reach the dead state, isn't it so? So that is, a thread is terminated or dead when a thread comes out of the run method. A thread can also be dead when the stop method is called in some cases. That's the reason why a thread can also be called dead when the stop method has been called. It can be called from the new state. Instead of calling the new thread from a start method, if you call the new thread with the stop method, it can directly reach the dead state. Or from the block state, if you call the stop method, it can still reach the dead state. So basically, a thread dies or moves into the dead state automatically when its run method completes the execution of the statement. This is basically the life cycle method of a thread. So finally, I would say during the life cycle of thread in Java, a thread moves from one state to another state in a variety of ways. As I say that it can use the start method, or we can use the sleep method, suspend method, wait method, yield method, resume method, notify method. Because of these different methods, it can reach different states. This is because in multi-threading environment, when a multiple threads are executing, only one thread can use CPU at a time. This is very important point here. As I said, when multiple threads are executing, only one thread can use CPU at a time. All other threads live in some other states, either waiting for the turn on CPU or waiting for satisfying some specific conditions. Therefore, a thread is always in any of these 5 states at the end of the day. So this is basically a life cycle methods of a thread. I hope now you have understood what is thread and what is multi-threading and the different life cycle method of a multi-threading in Java. Okay, so far we have learned what is multi-threading and the different life cycle methods of multi-threading in Java. Now, why multi-threading? Okay, multi-threading will execute more than one process simultaneously. That's okay. But what is the need for us to have the multi-threading in programming? Let me show you this simple example for the better understanding so that you will understand the need of multi-threading. So what I'm going to do, I'm going to create a new project. So I can name this project as any. So let me call this project as a thread test. It can be any name. So here I'm going to just name them as thread test. I want to create the main class for that one. That is the reason why this box is checked. So I'm going to click finish. So here is my project, as you can see them here. So here is my class. The class has been created with the main function. Before I tell you why we need multi-threading in Java, the one thing that you should know is every Java program has got at least one thread. That thread is nothing but the main thread. So every Java program will have at least one thread. That one thread is nothing but the main thread. So what do I mean to say main thread? So let's say here I'm going to write a message. So inside I'm going to print something. I'm going to say welcome users. So this is the main thread. So within this main thread, this is a message that I want to print. I hope it's clear, right? Now what will happen if I want to write another message, if I want to print another message? That one can be simply done here. Any message, or maybe if you want to have another message, you can have them, right? So within this main thread, I think there is a misplacement of this one. Things are okay. Okay, I have created a simple class name called thread test. Within that thread test, I have the main function. As I said, every Java program will have one thread. In this case, whatever the thing that you write them within the main method is a main thread. So within this main thread, I have got 3 sub processes. So this one is a sub process, this one is another sub process, this one is another sub process. That I hope you remember, thread is nothing but a sub process. So here I have 3 threads, 1, 2, 3. If I run this one, what will happen? Let me run so that you understand. Basically, when you run this program, it is going to print all these 3 messages in the same sequence. So what do I mean to say same sequence? The first message is welcome user. So welcome users will be printed first. What is the second message? We need you. That is the second message, right? That's the reason why we need you has been printed here. The final message is this. we are happy to have you here, and then that message is also been printed here. So at the end of the day, we are managing to print all the messages in the same sequence. So this is the first, second and the third. What if I want to have another class? Maybe I'm going to have some methods inside. Maybe in that method I can have another message, isn't it? So what do I mean to say another class? So let me give you this example. I'm going to create another class. Maybe I will call this one as a test. So within this class, I'm going to create a method. I hope you know how to create a method. Let me create a simple method. I will call this one, I want to have a public method so that I can inherit that method into the different class. So I'm going to call this one as a void. Let me call this one as a message. Okay, so inside this message method, I'm going to print something. So let me copy this statement. I'm going to paste them here. So the message would be from different class. Okay, now if I save and run, the result won't be changed because it is still going to print welcome users, we need you, we are happy to have you. The reason is, yes, I have a different class, but I have not called this class within this main class. So if you want to print this message in the display, what you need to do, you need to create an object for this class that you have created. How to create an object, I hope you know. So you are going to pick the name of the class, then create an object. You are going to create a new as a keyword. What is the use of this new keyword? This new will allocate the memory for the object that you have created for this particular class, then followed by the name of the class itself. So this is basically a syntax for you to create an object. I hope you already know. Now what do I want to do? I want to print this message from this class test. If you want to print this message from this class test, what do you need to do? You're going to pick the object that you have created. What is the name of the object here? T1. Alright, you're going to use the dot operator. Dot operator basically we use to access the properties, right? So which method are you going to access from that class? The name of the method is message. So I hope you have seen the name of the method is message. So this is a method that I want to call from this class, from this main class, so that I will have the access to this message that are part of this method. So when I save and run, you will see the first message will be welcome users. The second message will be from this class test, because that is the one that I have placed them as a second thing. So it will go to this class, then it will pick this message, and then it will be printed here in the screen. Then the third message will be we need you, and then we are happy to have you here. What if I want to bring this thing towards the end of this class? So in this case, first message will be welcome users, second message will be we need you, third message will be we are happy to have you, and then the final message will be I'm from a different class, because this method I'm calling as a last statement from this main class. So these messages will be printed in a same sequence that you have given them here in the main function. If you want to test, you can run again so that you will see these three messages have been printed first. At the end, we are trying to call this class with the method name called message. Then that message has been printed at the end of the statement. Now my question to you is, what if I want to change the order of execution? Then maybe you might have that question in your mind. Why should I even change the order of the message that I'm going to print? Let's say there are instances where you really need to change the order of the messages. Let me give you an example based on this example that I have given you. So in this case, I have 4 threads. Threads mean sub-process. So this one is a first process, this one is a second process, third process, this is a fourth process. So according to your result, we are trying to print the message in a same sequence order, right? Same sequence of order. So in case, let's say, if this message takes forever to execute, what will happen? Then these other methods have to wait until this message has been printed on the screen. Why? because you cannot print the next message without printing this message. Let's say, and this particular message is taking forever to execute. In that case, these other statements have to wait forever as well. That's a reality, because you cannot execute these other 3 threads without executing the first thread, because according to the sequence, this one has to be executed first, and then this message would take forever to execute. In that case, these messages have also to wait until forever, because this message is not been printed. To avoid this problem, Java has introduced the method of multithreading. So what does that mean, multithreading? Let us go back to the definition for multithreading. Multithreading is nothing but where we allow more than 2 processes to access the resource simultaneously. When I say resource, is a CPU, because CPU is the one who is responsible to execute the process, isn't it so? So imagine if only one process is been staying there in the CPU forever. Other processes has to be in a waiting state. Waiting state in the sense, as according to the lifecycle method that we have seen, the runnable state. I hope in that diagram you still remember. There are processes that are being queued up in the runnable state. What does that mean? There is a particular process that are already there in the CPU. So remember the statement that I mentioned. In CPU, there is only one process can be executed at a time. By the time other processes has to wait, because you cannot put more than 2 processes at a time, because only one CPU can run only one process at a time. So other processes has to be waiting in a different state. It can be in a newborn state, or it can be in a runnable state, or it can be in a dead state, or it can be in a waiting state, whatever the state it can be. But different processes will be placed in a different state, but only one process can be reside on the CPU for the execution. Imagine in this case, this other processor will be stayed in the runnable state, and this one will be in the running state, and this process will take forever. So in that case, it doesn't make sense, isn't it? So because in some cases, let's say if this process is not working, in that case, let me just go and work on this process, because I want these statements to be printed. Because I don't want to wait for this process, because it's taking too long. So for the sake of time, let me start working on these 2 threads, so that I will see what I can do with this process later. So in that case, you need to push that particular process to somewhere, and then you have to allow these other processes to be executed, isn't it? So in that case, Java uses multi-threading concept. Now, how am I going to execute a process, or how am I going to execute these threads simultaneously? By using thread, as I said. Now, how am I going to create a thread? What is the procedure for me to create a thread in Java? As you know already, if you want to create a thread, there are 2 ways. First method is you are going to extend a thread from a thread class. So Java has inbuilt class name called thread. So we are going to extend our class from that thread class. That is one way. The second method is we are going to implement a runnable method. So these are all the 2 ways that you can follow to have a thread in your program, or to have a multi-threading concept in your program. So in that case, what do I mean to say to have a multi-threading concept in your program? So that you can allow more than one process to access the CPU simultaneously. So let us first discuss about how to create a thread from extending a thread class. So there are some procedures that you need to follow in order to extend the thread from a thread class. So what are all the procedures? Here we go. If you want to extend a thread from a thread class, the first step is we are going to create a class that extends from a thread class. That is the first step. Remember, if you want to create a thread, first method is extending from a thread class. So if you want to extend the class from a thread class, you are going to create a class that extends from a thread class. So that is the first step. Then the second procedure is you are going to create an override run method. That is the second step. third step is you are going to create the object for the thread class that you have created. That is the third step. So the final step would be you are going to start the same thread that you have created. So these are all the 4 steps that you are going to follow. Let me show you this example so that you will understand how I am going to apply this extending a thread class method to create a thread. So let me open my text editor again. Let me create a new project. So here I'm going to name as extend method. I'm going to click finish. So here, as usual, for example, if I copy all these, and then paste them here. So let me remove this part because I don't have any other class. I just have only one class. So in this case, if I save and run, what will happen? It's still going to be executed in a same order. So first message will come first, second will be second, third one will be third. What if I want to change the order of execution? That's when we are going to use the multi-threading concept. So multi-threading concept, the first method is extending from a thread class. So here what I'm going to do, so I'm going to create a class. I can name them as any. Let me call this one as a 1, class 1. Okay, here within this class, I'm going to have, sorry, the keyword is wrong because I've used uppercase, it's a lowercase. So every keyword must be start with a lowercase. Basically, all the keywords will be in the lowercase in Java. So here within this method, what I'm going to do, I'm going to have a method. So void test. So within this void test, I'm going to have, let me just copy and paste. So I will call this one as I'm from class 1. If you want to access this method from this class, what you need to do, you're going to create an object, same like previous one. The name of the class is this one. I will call this one as a 1 equals new keyword and the name of the class. So inside I'm going to access 1 dot, what is the method that I have? Test. So if I save and run, what will happen? The message still has been printed in the same sequence of order. So for example, the sequence is this. First message is welcome user, second message is we need you, third message is we are happy to have you. Finally, I'm going to execute the method from this class name called 1. That is the reason why I am from the class 1. So still there is no changes. Now this is when we are going to apply the multi-threading concept using extending a thread class. So here I have a class, observe closely. So here I have a class name called 1. So if you want to make this class under the threading concept or multi-threading concept, what you need to do, this class must extend from a thread class. For that you are going to use extend as a keyword. Where are you going to extend from? From the thread class. Okay, there is a first procedure. I hope if you have seen the slide, the first one is we are going to extend the class from a thread class. So this is a procedure where you can extend this class from a thread class. So what is the next thing? You are going to have an override run method. So here instead of void test, I'm going to have run method. So I'm going to have, let me have a access specifier as public void. It can be anything. So let's say this is a void run method. Remember, I said you're going to create an override. So here you're going to have an annotation called override. So if you click here, it will even give you add override annotation. So in order to create a thread class, there are 2 ways. First one is we are going to extend from a thread class. The first step is we are going to extend this class 1 from this thread class. So we are trying to make this one as a multi-threading. The second step is we are going to create an override run method What is the third method? You are going to create an object for the class. So what is the class name? The class name is 1. So how to create an object? Same procedure. The procedure is you are going to pick the name of the class followed by an object equals a name of the class. What is the final step? So instead of using the method calling, so when I say method calling, you pick the object, then you put dot, then you call the method, whatever the method that you have them in this particular class. Isn't it so? Now in this case, instead of using the method, you are going to call the method as start. So what will happen in this case? The thread will be started. So in this case, we have implemented the concept of multithreading. So when I say we have implemented the concept of multithreading, what does that mean? This output is not going to be displayed in the given sequence. It can be displayed in a different sequence based on the priority. So when I say based on a priority, maybe let's say this process has to be executed first. In some cases, if this process takes forever to execute, in that case, we are going to push this particular thread to a different state. It can be in a waiting state. We can otherwise we can suspend the thread, whatever. There are different lifecycle methods we have seen. There is a different method that can be used to push our thread into the different state. Let's say this state is being allocated with a sleeping time of 3000 milliseconds. In that case, it's a 3 seconds. So this one will go to the waiting state for 3 seconds. So in that case, this other processor will take to the CPU, maybe one among these processors will be executed by then, right? So when I run this one, what will happen? The expected output would be in a different order. So we are going to print the statement in a different order, not in the same sequence, just because of the multi-threading. So when I go and run, as you can see them here, the first message is welcome user. Yes, we need you. We are happy to have you, and I am from the class 1. Okay, it's as for now it's displaying in the same sequence. So run again. So in this case, even the result as 2 printing in the same sequence. What does that mean? It's not necessarily our program is not working. Maybe the reason could be that this process is not taking forever time to execute. Maybe this process is still executing within the time frame. No wonder that it's not allowing the next process to execute, because maybe this process is not taking forever the time to execute this process. Maybe this process is being executed within the time frame. Even this process has been executed within the time frame. Even this process has been executed within the time frame. So that is the reason why the result is still displaying in the same sequence. It's not necessarily we have done some mistakes. So what I can do, let me modify the program somehow so that we will see exactly how this multi-threading has been working. So here in the just printing a message, so let me have the for loop so that we can have the iteration. So here I'm going to have a for loop. So within the for loop, what I'm going to do, let's say I'm going to print a number starting from 1 to 5. So for that I'm going to say integer I is equals to 1, then I less than or equals to 5, I plus plus. So inside what I can do, I'm going to have some printf statement. So within this printf statement, what I'm going to do is, maybe let me just have the tab key. I'm going to say from, this is from just a message, I hope you know, from 1. So instead of saying 1, I will say thread 1. So it's going to print the message starting saying from thread 1, and then we need to print the message, right? So here let me just put the colon. Then I'm going to say I value is equals, where are you going to get the I value from? From the I, because every time when you iterate through, the I value will be printed, right? So if this condition fails, maybe outside the loop, what I'm going to have, let me copy and paste for the sake of time. So here the message that I want to print them is the exit of A, because this for loop will be executed as long as this condition is true. Let's say if this condition fails, it has to execute something, right? So maybe here the message would be, I would say it's exit from thread 1, right? What does that mean? So this loop is going to be executed as long as this particular condition is true. If the condition is false, then it will come and print it is the it's a exit from a thread 1. Let me save. Then what I can do, let me create another 2 classes. It's not necessarily a Java program will have only one thread, only one class. We can have more than one class. So in that case, for the sake of time, again, what I'm going to do, I'm just going to copy. Let me paste them here. So instead of class 1, let me call this one as a 2. So here instead of 1, I'm just going to say 2. Even here I'm just going to say 2. Just for the difference, instead of calling this one as an integer I, let me change the name of the variable so that it will be easy for us to identify which process has been executed first. So even this one is going to be J, right? So let me create another one. What I am trying to do then here is to create as many classes possible so that it will be easy for me to demonstrate how this multi-threading has been working here. So here instead of class 1, class 3, so instead of I, let me name this one as a K. So it's also K, it's K. This is 3, this one is K, even this one will be K. I hope you have understood what I am trying to do them here. So it's J, this one is 3. So basically what I have done, instead of having one class, one thread class, I am trying to have 3 thread classes. So this is a class 1. I have implemented the thread class because there is an override run method, and then there is another class with the override run method. This is another class. So basically we have 3 thread class, right? So if you want to print the messages, or if you want to start this thread, what you need to do, you have to create an object for each of these classes because they are different classes, right? So if you want to have access to this particular thread class, the first step is you are going to create a class that extends from a thread. The second step is you are going to create an override run method. So what is the third step? What is the third step? I hope you remember, right? You have to create an object for the class that you have created. So you have created 3 classes here, 1, 2 and 3. Now you need to create an object for those 3 classes that you have there, right? So here, let me just remove this part. Let's say system.out.println welcome users would be the first message. Then from there, we are going to create an object for those 3 classes that we have created. What is the first class name? 1. Let's say I'm going to create an object as 1 equals new keyword followed by 1. So this is an object creation for the first class. So what is the second class? The second class name is 2. I'm going to create an object as 2 equals, I'm going to call the new keyword and the name of the class. Right? And what is the third class? The third class is 3, I think. Then 3 is the name of the class equals new 3. I hope these are all the class names for these 3 classes. Yes, right? This is 3, that is 2 and 1. Now that is the third step. If you want to start those classes that you have created, what you need to do? You have to use the method name as start. That is the final step, isn't it? So create a class that extends from a thread. That's the first step. The second step is you are going to create an override void run function. Yes, we have done that one. What is the third step? You have to create an object for the classes that you have created. Yes, I have created an object for the classes that I have created. Is there? Then what is the final step? You have to use the start method to start the thread. So how are you going to use a start method? Simply you are going to pick up the objects that you have created for each of those classes. So what is the object for the first class? 1. Dot. What are you going to use now to start the thread? You are going to use the method as start. Simple as that. Pick the second object, The second object is 2 dot start method. Yes. Then 3 is the third object dot, we are going to use the start method. So what will happen? So according to this main function, this is my main function. So what before the examples that we have seen, the first message would be this one, the second message would be from the class 1, the third message would be from the class 2, and the fourth message would be from the class 3. So what does that mean? Basically it has to print the welcome users, followed by it has to print the element starting from 1 to 5 from a thread 1, then it has to print its exist from the thread 1, then it has to come here, then it has to print from the thread 2, it has to print 1, 2, 3 up to 5, then it has to print this message, and then even here it has to come to the 3, it has to print 1 to 5, then it has to print it is exit from the thread 3, isn't it? So this is how the sequence that we have written them here in the main function. But if you follow the same sequence to execute the process, that problem will exist. What does that mean? What if the thread 1 takes forever time to execute? In that case, process 2 and process 3 has to wait, right? To avoid that one, we are using this multi-threading concept. So what does that mean, multi-threading? Where we are extending a class from a thread class. So when I run this one, you will see the result will be mixed up. So what does that mean? There is more than one processes that are accessing the CPU simultaneously, meaning they are no longer waiting for other process to be completed. They will just wait for a few time. If that process is not done by that time, in that time, other processor will go to the CPU based on the priority, that particular process will be executed. So what do I mean to say? Let me run this one so that you understand. As you can see them here, welcome users, the first message is from thread 1, I is equals to 1. So instead of printing from thread 1, I is equals to 2, the message that was printed here is 3. Is going to the thread 3 and printing the k value 1, 2, 3, 4, 5. Then the exit message is it is the exist from thread 3, and then from thread 2, the thread 2 has been printed j1, 2, 3, 4, 5, and then exit from the thread 2. Then it has gone to the thread 1 again, is printing the other messages. What does that mean? Maybe thread A, only I value is equals to 1 has been printed within the time period. Maybe the I value was, when the I value was 2, maybe it has taken too long time to print the message. That is the reason why those other two processes has taken over the time of the process, the thread 1. So that's the reason why when they see the I value 2 has taken too long time, between this thread 3 and thread 2, they are fighting for the CPU. In that case, based on a priority, thread 3 has got the highest priority. So the k is equal to 1 has been executed, 2, 3, 4, 5, because seems like this one is not taking too long time to execute. That is the reason why this process has been executed before thread 3. Now from there, thread 2 and thread A will be, thread 2 and thread 1 will be fighting for the CPU. In that case, let's say the thread 1 is taking too long. In that case, thread 2 has been executed. Finally, there is no other processes to execute. That's the reason why the processes have allocated the resources for thread 1. So now thread 2, I is equal to 2, 3, 4, 5 has been executed. Now we are mixing up the execution based on a priority. We are no longer going to wait for the sequence of order. Instead, we are going to allow more than one threads to access the CPU simultaneously. So in this case, what if I run again? The result will be changing based on a priority. For example, let me run the file again. We are no longer going to get the same result. The result might change. As you can see them here, it has already changed. Welcome user. The first thread that has been executed here is from the thread 3. And then these two are from the thread 3. Again, thread 1 has been executed here. Again, thread 2 has been executed. Again, thread 3, the output has been changed because it's based on a priority. CPU will allocate the resources to a different process. Now we have managed to execute a different process simultaneously. So in this case, we are no longer going to wait for one process to be executed and then other processes has to be wait until that process has been executed. We overcome that issue. Maybe There are instances where I have to see my boss first before my friend, because him would take long for him to solve his issue. But maybe for me it's just a few minutes. Maybe even in the shops, when you go there, you find that maybe you just bought a drink, but others have got a lot of things to bill. So in that case, maybe you can request, maybe you have bought a lot of things, maybe you may take longer time. For me, just a drink, can I go and bill them? Can I go and pay my bill first before you? In that case, it can be done, isn't it? So same things happen here. If somebody takes too long time to execute, we are not just allowing them to take forever time to stay there, because we can be done in few minutes time. So I'm not afford to wait for a longer time. So in that case, I'm going there, I'm going to execute my process. Maybe when I'm done, you can still go and view your things that you have purchased. So that is exactly what happening here. So this is a major use of having multi-threading in Java. So where you can allow more than one process to have a concurrent access, to have a simultaneous access to the CPU. Now there is a question here. Can we call the run method directly? So what do I mean to say run method directly? So instead of using this start method, basically what we usually do, we create a method. If you want to call this method, we create an object, then we call this name of the method, isn't it? So even in the previous example, I named this one as a void message. So if you want to print the messages within this particular method, what do? You create an object, you put dot, then the name of the method, isn't it? So here, instead of using the name of the method, we have done start method. So what if I want to just use the run method instead of calling the start method? What will happen? Let me do this, because the name of the method is run, right? This is basically how we call any method. So here I'm going to call run method. I hope you have understood what I mean. Instead of using the start method, what if I just want to call the actual name of the method that I have them here? So what will happen? So in that case, let me show you. The threads will be printed in a same sequence. So the first message will be welcome user, then it will go to the thread 1, it will print all the messages, then it will exit from the thread 1, then it will go to the thread 2, then thread 2 will be printed, then it will exit from the thread 2, then it will goes to the thread 3, then it will print all the messages from the thread 3, then it will exit from the thread 3. So here there is no change. There is no simultaneous access between two threads. So if you use the run method, it won't work like a multi-threading concept. It's still going to be executed in a same sequence. So you have to make sure when you call that each thread that you have created with a different class, you have to start those thread class with the start method, not with the same name of the method. So in that case, you just have to use start. You have no option if you want to have a multi-threading concept. If you want to access, if you want to have a concurrent access, if you want to have a simultaneous access between threads, you just have to start that thread with a method name called start, not with the run method. I hope now you have understood how to create a thread using extending from a thread class. Now the second method to create the thread is by implementing the runnable interface. So let us see the procedures or the steps that we need to follow in order to have this implementing the runnable interface. The first one is declare the class as implementing the runnable interface. So I'm going to my browser text editor here. So instead of extends thread, I'm going to say implements runnable, isn't it? So that's the first procedure. So I'm going to call this one as a runnable. So what I'm going to do, I'm going to just copy this part and paste everywhere. Even for this part, I'm going to copy and paste. That's the first step, isn't it? So then the next step, implement the run method. Yes, of course, I have the run method for each of these classes. the override run function. Yes. And then what is the next step? Create a thread by defining an object that is instantiated from the runnable class as the target of the thread. Create the thread by defining an object that is instantiated from the runnable class as the target of the thread. So for that, what I am going to do, in the main function, yes, I have created an object for each of those classes, followed by, they said I have to create an object for the thread class. So for that, I am going to create an object. I am going to call this one as a thread class. I am going to create an object T1 equals new. I am going to again get the thread class. So inside, as you can see them here, create the thread by defining an object that is instantiated from the runnable class. So what is the instantiation? Instantiation, which is nothing but the object creation, right? So I'm going to get the object for the class 1 as a parameter for this thread class. That is what it means. So maybe there is a typo error. It's not the thread, it's a thread. So I'm going to create an object for the class 1, as well as I'm going to create the object for the thread class. For this thread class, I'm going to pass the object of the first class as an argument. Isn't it so? So now I'm going to do the same for the rest of the classes. So I'm going to copy, I'm going to paste them here. So instead of 1, this one is going to be 2. So this object, instead of T1, I'm going to call this one as a T2. So here is 3, so the object here is 3, so THREE, so this one I'm going to call them as T3. As simple as that, right? That's what this step says. Create a thread. Yes, I have created by defining an object. I have created a thread, defining an object. Yes, I did. Then from there, that is instantiated from the runnable class. So what is the runnable class here? We have got 3 classes, of course. Class 1 implements runnable, class 2 implements runnable, class 3 implements runnable, isn't it so? So here I am going to say the object that is instantiated from the runnable class as the target of the thread. So what is the target? Target is the object that we have created for each of these classes, isn't it so? Class 1, this is a target, so this is where I am going to show. So I am going to pass this object as a target here for each of these thread classes that I have created. That's it. Then what is the next one? Call the threads start method to run the thread. So here I have the start method, but I have to call the thread start, not the object for the class that I have created. I'm going to pick the object for the threads that I have created. For the first one, I have the object as T1. For the second one is T2. For the third one is T3. I'm going to pick the objects for the threads. That's the reason why I say that call the thread start method in the run step. Then that's it. Maybe that's the thing. I think when I save and then when I run, you will see the similar result like extending from a thread class, because we are going to allow more than one process to have the CPU simultaneously. When I run this one, you will see still this process has been mixed up. First we are running I is equal to 1, k is equal to 1, j is equal to 1, k is, the process has been mixed up. It's not, it has not been executed in this given sequence. The process has been mixed up, maybe based on a priority. We allow some process to execute first, some process to execute later part of the program. So here we have achieved to have access simultaneously between 2 processes, between more processes, not necessarily 2 processes. It can be any number of processes, but we made sure that those processes have simultaneous access to the CPU. So this is how you can have multi-threading in Java. First example was by extending from a thread class, and this example you can implement a runnable method to have a simultaneous access between 2 classes. Now the question would be, yes, we have two methods to create a multi-threading process. What is the difference exactly? Which one I should go for it? Because you have extending a thread class, you can extend from a thread class, or you can use a runnable method. Both are helping me to have a simultaneous access between the processes. Now, which one is more efficient? Which one I should go for it? What is the difference exactly between the runnable and the extending from the thread class? Let me show you the difference between the runnable method and the extending from the thread class. As I said, we have two different methods to create the thread. Which method is effective? Which method I should go for it? Because I can even use either extending from the thread class or runnable method. Which method is safer? Which method is faster? So in that case, implementing a runnable is the preferred way to do it. Here you're not really specializing or modifying the thread's behavior. You are just giving the thread something to run. That means composition is the better way to go. Java only supports single inheritance. Remember, Java doesn't support multiple inheritance. Java only supports single inheritance. So you can only extend one class. So in that case, runnable method is a better option. Instantiating an interface gives a cleaner separation between your code and the implementation of the thread. Isn't it so? Finally, implementing runnable makes your class more flexible. If you extend the thread, then the action you are doing is always going to be in the thread. However, if you implement runnable, it doesn't have to be. You can run it in a thread or pass it to some kind of executor service, or just pass it around the task within the single threaded application. So it always recommended is the best way that you can use the runnable interface to create a thread. I hope now you have understood what is multi-threading in Java, the different life cycles methods of multi-threading, and how to create a multi-threading in two different ways. I'm sure that you even know the purpose of having the multi-threading in Java. Now we are going to learn about the different thread methods that we were discussing in the lifecycle methods of thread. So now I'm going to explain you what is yield and what is sleep and what is stop thread methods in thread and what can you do with these methods. Let me show you this simple example for the better understanding of these three methods. Basically, the first one is a yield, isn't it? So sleep, I hope you know, when you pass the parameter for this sleep method, that particular process will go to the sleep mode in that given amount of time. Then stop method, I hope you still remember in the diagram of lifecycle method, stop method does a lot of things. It will stop the thread or it will suspend the thread. Stop method, when you apply the stop method, it can straight go to the dead state, or the thread can be suspended, or maybe you can stop that thread for a specified amount of time. So you can do a lot of things with the stop method. I will show you an example program so that you will understand. So what exactly this yield method? So basically yield method, if you, for example, let's say if you want a thread to relinquish the control to another thread to equal priority before its turn comes, we can do that one by the use of this yield method. So I don't want to confuse you much. Let me show you this example for the better understanding. So what I'm going to do, I'm just going to make use of the same program that we were using to create the multi-threading concepts. So as you can see them here, the same example, class 1, they're using the extend method. So we are trying to extend this class from the thread class. So I have 3 classes. So I'm trying to use the same examples that we are going through for this particular tutorial. So the same example, class 1 extend thread, class 2 extend thread, class 3 extend thread. So here what I'm going to do, so in this for loop for the class 1, inside I want to have a condition. So I'm going to say if the I is equals 1, then I want this process to be yield. Okay, then you will see how it's going to work. Like don't get confused of seeing this. What is this yield? As I say that yield method is being used in case if you want the thread to relinquish the control to another thread with the equal priority before its turn comes. Okay, that is the use of this yield method. The next method what I want to use them is we have stop method and the sleep method. So here maybe in the class 2 inside, let me write the condition. So the stop method, what I'm going to do, maybe it's going to print the j value when the condition is 1, when the condition is true. In case if the j value becomes 3, I want to stop. So what does that mean? It's going to be executed until the j value is 1, 2. When the j value becomes 3, I want to stop this particular thread. Then the final one is sleep. I hope you know sleep method means we are going to pass the amount of time that process is going to be there in the sleeping mode. Then again it will go back to the runnable state before it gets sent to the running state. So in the process C, I mean in the thread class 3, I want to use the sleep method. So here after printing k, I'm going to set the condition, because remember every thread will be in a different state based on a different condition. So that is the reason why we are using the if condition, because we are trying to say, okay, process k, when the k value is equal to 1, it can run. K value is equal to t, it can run. But when the k value is 3, I want to send that process to the sleeping mode or waiting state or stopping or resuming or whatever the state, whatever the methods that we can use them in a thread. So every state will come to play on a given condition, on a specified condition. That is the reason why we are using the if conditions here, just because yes, this thread can run, but when the thread value is equals to this one, I don't want that process to be executed. Instead, I want to stop the thread. I want to send them to maybe sleeping mode. I want to, let's say I want to stop the thread execution. Maybe I want to say I want to have the yield method. Yield method is that process will stop executing, then the control will move to the some other process which has got the equal priority. So here for the sleep method, I'm going to say when the k value is equals to 1. So when the k value becomes 1, I want to have a condition. So what is the error here? Okay, it will go, let's say here I'm going to say sleep for 1000 milliseconds. So what does that mean, 1000 milliseconds? 1000 milliseconds basically is equals to 1 second, isn't it? So for 1 second, this process will go to the sleeping mode. After 1 second, it will come back to the runnable state before it reaches the running state. So as soon as when I put sleep method, you have see there here unreported exception, uninterrupted exception must be caught or declared to be thrown. So what does that mean? When you use the sleep method, it's supposed to be enclosed in a try block and followed by a catch block. This is necessary because the sleep method throws an exception. As you can see them here, the sleep method will always throws an exception which should be caught. If you fail to catch the exception, then program will not compile. So you have to enclose this one, this sleep method, with a try catch block. So for that I'm going to have the try. So within that try, I'm going to have the sleep method. Then this try block should come with a catch. So here, so that it can catch the exception. So here I can say it's going to catch the exception E, whatever. And then inside, just going to have the empty block. Right? Basically, when you have, remember, basically when you have a sleep method, it should enclose with the try catch block because it will throw an exception. That is the reason why I'm trying to enclose this one in the try catch block. Now we have managed to implement those three methods. Yield, what does that mean? When the I value is equals to 1, it's not going to be executed. Instead, it will allow a different process to be executed, just because yield means it's handing over. Yield means, as I said, we are using the yield method in a thread A. So in this case, sorry, not thread A, we are trying to use the yield method in the thread 1 at the iteration I is equals to 1. Therefore, the thread 1, although started first, it has to started first. So when I say started first, we have just created an object for each of those threads. So now I need to call those threads, isn't it? So here, let me just have a message, system.out.println. So this one, let me call this one as a started thread 1 as a message, followed by I want to start the thread. If you want to start the thread, what do you need to do? You have to pick the object dot start method, isn't it so? So now I'm going to do the same. So here, let me just copy and paste. Copy and paste. So here, instead of start, I'm going to say 3, because that is the object for the third one. So this one is also going to be 3. So this one will be 2. Even this one is a 2. I hope there is no issues here. What exactly what I have done? I have created an object. Then I want to start that process. Remember, you have to use the start method. If you use the run method, the output will be in a sequence, the same sequence that we have written them here. But here we don't want to be written them. We don't want the process to be executed in the same sequence. Instead, we want them to be executed based on a priority. So even here we have set 3 different conditions. First one is an yield. What does that mean? Yield means yield uses the method. Basically, this yield is a method in thread 1 at the iteration I is equals to 1. Therefore, the thread A, although started first, because here in the main function I'm trying to start the first one, isn't it so? So this thread 1, although started first, has relinquished its control to the thread B, because that is the thread that follows immediate after thread 1. It has to start first. Just because of the yield method, is relinquished its control to the thread B. The stop method in the thread 2, I mean not thread B, thread 2 I mean. So again when it reaches to the thread 2, there is a stop method, right? This stop method in the thread 2 has queued it after implementing the for loop only 3 times. That's the reason why if j is equals to 3, so it's going to execute it 3 times. After 3 times, it's going to queue, it's going to stop. Then from here, the control has to reach the thread 3. So here again, I have put k is equals to 1. The k value is 1. Even this process is going to reach the sleeping state. Then what will happen? Again, it will go back to the thread A, then thread A. Oh, sorry, thread 1 will be executed, thread 2 will be executed, and then thread 3 will be executed. Let me run this one so that you understand what do I mean to say. Class 1 is not supposed to be running at the first, just because I'm saying if the I value is equals to 1, yes, it's going to execute this one, this statement, welcome users, then from the started thread 1, then from here I'm trying to start the conditions that are inside the thread 1. So when you start the conditions that are inside the thread 1, here I have the condition if the I value is equals to 1, I should not run this one, because the thread has the yield method, meaning is going to relinquish its control to the thread B, because I'm not going to execute because the I value is 1. Then it should come to the thread 2. So when it comes to thread 2, it's going to execute I value is equals to 1, I value is equals, j value is equals to 1, j value is equals to 2. When the j value becomes 3, this one is not going to be executed, meaning it's going to print only j value 1 and 2. And when j value becomes 3, is going to stop. It's not going to execute further. Then from here it will come. Then when the k value is 1, it will send to the sleep mode for 1 second. Then from there it come back and execute. So as you can see them here, the order of execution is first is executing this one, this statement, this statement, this statement, and then the j has been executed up until 3. Then it will stop. Then k has been executed. Then again here I has been executed 5 times. Then we are going to execute k values, the remaining k values. If you can notice one thing, when the j value is 4 and 5 is not been executed, just because what we have done them here is a stop. So we are going to stop if anything reaches, because j value is 1 is going to be executed, j value is 2 is going to be executed, even when the j value is 3 is going to be executed. Then from there is going to come and check the condition. If the j value is equals to 3, don't execute. Maybe after 4 and 5, don't execute. So that's the reason why j is equal to 4 and 5 has been stopped here, is no longer been executed. So basically we use these different methods to place each thread in a different state of lifecycle method. Then from there it will reach the running state based on a priority. So this is how yield, stop and sleep method would work. Now let us learn about thread priority. In Java, each thread is assigned a priority, which affects the order in which it is scheduled for running. The threads that we have discussed so far are the same priority. The threads of the same priority are given equal treatment by Java scheduler, and therefore they share the processor on a first come first service basis. Basically, if you want to set a specific priority to each of the thread, so this is a method that can be followed. So if you want to set a specific priority to your process, this is a method. You are going to take the name of the thread and then you are going to use dot set priority as a method. Inside you are going to pass an integer number as a parameter. Basically, what is this integer parameter? When you pass the number as 1, what does that mean? That thread will have the minimum priority. What does that mean? It will be executed at the end. That thread will be executed at the end. So when you set the number to 10, that thread will have the maximum priority. What does that mean? That process will be executed first. When you set the number as 5, that one will have the normal priority. So this is how basically you can set a thread priority to each of the thread. If you want to execute that process first, set them to maximum. If you want to execute the process at the last, set that priority to minimum. If you want to execute that as a normal priority, set that one to 5. So this is how thread priority can be done in Java. So now what I'm going to do, let me just go back to our IDE. So here I'm just going to take the same example. So what I'm going to do is just I want to get rid of this yield method here, and then I want to remove the stop method here because we are going to discuss about the priority. So I don't want to stop, yield, or either the sleep method. So I'm going to get rid of all this method. So this is basically what I've done. I've got 3 different threads. Thread 1, where I have the for loop, it will execute. Then thread 2, I have the for loop, it will execute. And then thread 3, I have the for loop, it will execute. In the main function, what I am going to do, I'm going to create an object for each of those threads. So let me just get rid of these things. Okay, so what I've done, this is object for the first thread, this is object for the second thread, and this is object for the third thread, isn't it? So this is simple, right? Now what I'm going to do, I'm going to make use of this priority properties that comes with the thread. So if you want to set the priorities, what is the first step? You're going to get the thread name dot set priority, isn't it? So I'm going to get the thread name. So in this case, what is a thread name? It's nothing but the object, isn't it? So the thread name here is an object. So here I'm going to get 1 dot, then followed by what am I going to do? I'm going to use the property as set priority. So inside I have to pass the value. So let's say here I want to pass the maximum priority. It can be represented in two ways. You can pass the number, or you can just pass this one as a parameter. So when you pass min priority as a parameter, what does that mean? That one is equivalent to 1. When you pass max priority, what does that mean? That one is equivalent to 10. Isn't it so? You can pass either number or this same property. So here, instead of using the number, what I'm going to do, for the process 3, I'm going to say thread dot max priority. So what does that mean? This one will be assigned as a maximum priority. Then the next one, what I'm going to do, basically, let's say for the, let me pick the second one, 2 dot, I'm going to set the priority. So I have to use set priority. So inside, what I'm going to do, I'm going to take the object of the first thread class. So that is, what is the object for the first thread class? 1, right? Now I'm going to say dot, I'm going to get the priority of that first object. So get priority. So this one, if you want to set the priority, you are going to use set priority method. If you want to get the priority, there is a method name called get priority. So what this method does exactly, it will get the priority that is assigned to the first thread class object. Then let's say I'm going to add +1. Sorry. So here I'm going to say I'm going to get the priority for the first class. I'm going to add with 1. So what is the error here? Maybe there is a typo error. Yes, typo error. Priority. Right? So what is this set priority? We are trying to set the priority to a thread. What does that mean? Get priority. We are going to get the priority of a particular thread class. In this case, I'm going to get the priority from the class 1 and then going to add 1. So that final will be set to the thread 2. Simple. I'm going to get the priority for the first class. For example, the priority is equals to 4, let's say, and then we're going to add 1. It will be 5, isn't it so? That 5 is the set priority value for thread 2. Then let me get the third one. Let's say 3 dot. So for this one, what can I say? Maybe I can say set priority. Set priority. So let's say here I'm just going to pass the number. So in this case, I'm going to pass the number as 5. So you can pass that property or you can pass the value. I'm trying to show you the different ways, right? So everything is done. So what is remaining here is we need to start. So 1 dot start, so that the first one will be started. 2 dot start, so that the second one will be started. 3 dot start, so that the third method will be started. Let me save and run. Now this one would work based on the priorities that we have set them here. So when I run this one, exception in thread main Java illegal exception. So illegal argument exception. So where is it coming from? Dot set priority. So let me assign this one as a thread dot minimum priority. Let me save and run. I don't find it. Okay, it is working. So just because of the number, if you use minimum priority, just use the same properties. So here, what I've done, the first method is the third thread class. I've set them to the maximum priority. Then the second thread class, I set the priority. What I'm going to do, I'm going to get the thread 1 priority and then I'm going to add +1. So here 1 is nothing but I'm going to set the priority. That priority is the minimum priority. Basically, the process 1 has to be executed at the last, isn't it? So just because that one has the minimum priority. No wonder that in the output, the thread, the thread 1 has been executed at the end just because I have set the priority as minimum priority. Then here when you go up, the class 3, thread class 3 has set the maximum priority, so it's going to be executed first. This one is from the class 3. Then what about class 2? The thread class 2 is get the minimum priority from the 1, then set 1 plus 1. So what does that mean? This one is going to have plus 1 more priority than the 1. What does that mean? That one has to be executed second, isn't it? So this one is the least, this one is the maximum, this one has a normal priority. That is the reason why here the class 2 has been executed between the class 3 and class 2. So this is how you can set priorities to the thread, so that you will assign a specified thread to be executed first, and that so that the specific thread can be executed first. At the same time, there are some threads can be executed at the end. So hopefully you have understood how the priorities in thread can be used. Now let us learn about what is synchronization in multithreading. So far we have seen threads that use their own data and methods provided inside their own run methods. What happens when they try to use the data and methods outside themselves? On such occasions, they may compete for same resources and may lead to serious problems, isn't it? So, for example, one thread may try to read a record from a file while other is still writing to the same file. Depending on the situation, we may get strange results. For this, Java enables us to overcome with the help of synchronization. So that is the use of synchronization. In case of Java, the keyword synchronized help to solve such problems by keeping a watch on such locations. For example, the method that will read information from a file and the method that will update the same file may be declared as synchronized. As you can see them here, there is an example syntax. In case if you want to have a method as a synchronized, you are going to use synchronized as a method and followed by name of the method. So when we declare the method as a synchronized, Java will create a monitor and hands it over to the thread that calls the method first time. As long as the thread holds the monitor, no other thread can enter the synchronized section of a code. A monitor is like a key that the thread that holds the key can only open the lock. So this one will be locked. You cannot open until otherwise this process has completed this particular task, right? So whenever a thread has completed its work of using the synchronized method, it will hand over the monitor to the next thread that is ready to use the same resource. So let me give you a simple example so that you will understand better. So what is the use of this synchronization? Basically, when you want to complete a particular task, that process has to be completed before you allow the different process to come and access that resource, isn't it so? So how are you going to making sure that this process has been completed before I allow the different processes to be executed? In that case, we use the concept of synchronization. We are going to use the keyword as synchronized, so that that process will be locked until that particular process has been completed. If some other process want to try to access that particular process, then that process will be locked, will be a key to access that particular part. Basically, we are going to lock until that process completes its task. Let me give you this example so that you will understand. So I'm going to open my NetBeans. Now let me create a simple program using synchronized method so that you will understand how synchronization will be done in Java multithreading. So I'm going to my new project. I'm going to select the Java application. I'm going to click next. So here you can name them as any. So let's say here I'm going to call this one as test synchronization, any name, right? So I'm going to click finish. So my class has been created here. So what I'm going to do here, let me create another class, and then I'm going to call this class as whatever the name. Okay, within this class I'm going to have the method. I hope you know what is method. So let's say I'm going to call the method as void print message. This is the name of the message, sorry, the method, right? So within this print message, so let's say I'm going to pass a parameter. It's an integer parameter. Okay, our print message, or maybe print value, whatever. So let's say print value. It would make sense as long as I've passed the parameter as an integer number. So inside this method, I'm just going to have the printf statement, system.out.println. So within this printf statement, what I want to print them, okay, instead of writing just a printf statement, let me have a loop. So I'm going to have a loop, for loop. I'm going to say integer I is equals to 1, I less than or equal to, let's say, 5, I plus plus. So if it is the case, what I want to print them here is this, maybe, what is it? Okay, so what I want to print them here is the same I value. Oh, okay, I want to take this parameter n, I want to multiply with I value here. Okay, I hope everything is clear. There is no issue. Just simple. There is a method with a parameter n. So whatever the value that I give for this n will be multiplied with these I values every time. Right? When the I value is 1, let's say the n value is 2, 1 times 2, 1 times 3, 1 times, sorry, 2 times 2, 3 times 2, 4 times. That just simple logic, right? So that's how it's going to be worked. So what is it here? Legacy test sync. Okay, no, it's simply a class. This one is a different class. Maybe let me. So this one is a different class, and this one is a different class. This class public static. What is the mistake here? Okay, we will correct it later. So I have 1, 2, 3 curly braces open. So I have to 3 curly braces closed. That's the thing, right? So now what I'm going to do, let me invoke the sleep method. I hope you know what is sleep method. Even in the previous example, we have seen about the different thread methods. Sleep method means we are going to send that particular process for a sleep mode with a given time period. So let's say when I give the time period as 400 milliseconds. So for that 400 milliseconds, that process will move to the any other state from the lifecycle method. Then after 400 milliseconds, it will come back to the runnable state. From there, it will reach the running state. So here I'm going to have the sleep method. So you can just say sleep, or you can say thread.sleep, isn't it? So let's say I'm going to say sleep is 400. So I hope you still remember, if you want to invoke the sleep method, it has to be come with a try catch block, because it will throw an exception. That will be the import thread, import Java, whatever. Then again, yes, surround the statement with try catch. Yes, it has been surrounded with a try catch. So if you want to have this one inside, you can have them. Otherwise, it's not necessarily you need to have them. You can still have the empty thing. There is no problem, right? So let me save. So here, okay, you can say just sleep or thread.sleep. So let me cancel this one. You just add thread. Sleep method. Okay, so 1, 2, 3, 4. Okay, this one I've closed them here, this one I've closed them here, so I need to have another closing parenthesis just to make sure to close everything properly. So basically this is a class, this is a method for the class. Within that method, what I'm trying to do, whatever the value for the n, I'm going to multiply with this I value each time, and then I want to send that process to the sleeping mode for 400 milliseconds. So every after 400 milliseconds, it is going to print the value of this n times I. That's a simple thing, right? Now what I'm going to do, I'm going to create a class that extends from a thread class. So what you need to do, you're going to create a class with a class name. Let me call this name as my thread 1. So this class I'm going to extend from a thread class. For that, the keyword is extends. Where am I going to extend from? From the thread class. So this is one of the way to create a thread. So inside this thread class, I'm going to create an object for this class A. So the class is A. I'm going to create an object for that class A. Let me say obj. Okay. Then what I'm going to do here, I'm going to have the constructor. I hope you know what is constructor. The constructor name has to be the same name as the class name. What is the class name here? The class name is my thread, isn't it so? So here I'm going to have the constructor. So this constructor name has to be same name as the class name. Then let's say this constructor, I want to have them as a parameterized constructor. So if you want to have the parameterized constructor, let's say I'm going to take the class A and the object for the class A, just like this, right? So here inside, sorry, it's a constructor. So I need, it's a constructor is a function, same like this void print value. This is a normal function, this is a constructor function. So inside this function, I'm going to pass the value for this object that I have created. So how am I going to pass the value? So I'm going to say this dot object. I'm going to say this one is an object. I hope you know the use of this keyword. I'm just going to take this as a keyword. Here I'm trying to pass this object is nothing but the same object. So I think since it's a class that extends from a thread class, I hope you know the procedure. Every time when you create a class that extends from a class, it should come with a override void run function or override run method. So here I'm going to create a override run method. Let me call this one as a public access specifier, void run method. So what is the use of this void run function? This is one of the rule if you want to extend a thread from a thread class. So this function has to be a override function. So as you can see them here, there is a notification here, add override annotation. So within that override function, I'm going to pass the value for the n. So how are you going to pass the value for the n? Obj dot the name of the function. What is the name of the function here? Print value. This is the name of the function, isn't it so? Print value is the name of the function. So I'm going to look for print value. So inside I'm going to pass the value. So let's say the value that I want to pass them here is 5. So that is the value for this parameter n here. As you can see them here, this 5, it's even showing me the tooltip saying it's integer n. So this 5 is the value for n. So what does that mean? Initially the n value will be 5. So 5 times I, what is the I value initially? 1. So it has to print 5. Then 5 times I value will become 2. 2 is 10, 15, 20. That is how the values would be, isn't it so? So it is going to be printed every after 400 milliseconds. That is what is going to happen, right? So this is a one thread class. Let's say I'm going to create another thread. So here I'm just going to copy and paste. So instead of thread 1, let me call this one as a thread 2. I think even this one would be thread 2. I think the rest of the things would be the same, isn't it so? So here instead of 5, let me pass the different value. So let me call this one as 100. Okay, So what I want to print them is 100. So it's going to be substituted 100 in place of n for this particular thread. So in the main function, what you need to do, since I have two thread classes, if you have a two thread classes, you need to create an object for those thread classes, isn't it so? So how are you going to create an object? Simple. First create an object for this class, because the class A is also another class. So I'm coming here, I'm going to create an object for the class A. So this is A. So let me create an object. So object, I would say small a equals new A. Okay, then what do I need to do? I'm going to create object for these two thread classes. So first one is my thread 1. So let me create an object for that. So here I'm going to say my thread. So I will call this one as a T1 equals, thread equals, I'm going to say new thread 1. Inside this thread 1 method, I'm going to pass this object as a parameter. Same applies to the second one. Let me copy and paste. So this one, let me call this one as a T2. This is for A again. Yes, this one is of course A. So this one is a thread 2 because this is a different thread class that we have created. So even this one is supposed to be thread 2 because I'm creating the object for these two thread classes that I have created. There is a thread 1 here, there is a thread 2 here. Thread 2 here, I was creating an object for those two, as well as I was creating an object for the class with the method name called print value. Now if you want to start those thread classes, what you need to do, you have to pick the object, as we know already, dot start method, isn't it so? This will start the first thread. Then if you want to start the second one, T2 dot the start method. When I save and run, let's see what will happen. It's printing the result as 5, then 100, then 200, then 10, 15, 300. You see that different threads are executed simultaneously, isn't it so? 5, 10, 200, 10, 15, 300, 20, whatever. So this is basically, yeah, of course, when it comes to the multi-threading, we are allowing more than one threads to have access simultaneously. But in some cases, there are situations where this process has to be completed first before you start this process, isn't it so? So basically what we are trying to do them here, initially at some point it picks this 5 and then multiplying with I value. At some cases is picking this 100 as a value and multiplying with this I value. What if I want to finish this thread class first before I start this thread class? In that case, synchronization will come to picture, because you cannot read something when the data has been not written there, isn't it so? For example, when there is a resource, only one process will be allowed to access that resource, isn't it so? So you cannot access that resource simultaneously. Remember, even we are trying to achieve simultaneous process, but at the CPU, in the main memory, at a time, we will allow only one process to get executed. So in this case, we are trying to mix up the things between the thread class 1 and thread class 2. To fix that one, so this method, we are going to make them as a synchronized method. What does that mean? Synchronized is like a lock. When that method is locked for the thread class A, thread class B has to wait until the thread class A has been done. So in that case, I'm going to use synchronized keyword. So what will happen when the process from the thread class 1 started execute this particular block of method? the thread class B has to wait until the myThread1 class is being done. For example, first when you start with this class, you have to finish before you start this class. That is what we are basically trying to do. Though it's a multi-threading, yes, we will allow multi-processes, multi-threads to execute simultaneously. In some cases, we have to execute a certain threads to be executed first before we execute a different thread. So if you notice this output, they are mixed up somehow because we are executing, in some cases it's executing from myThread1 class, in some cases is executing myThread2 class. That's the reason why the results are not organized. If you want to fix this error, we are going to use the synchronization concept, where we are going to introduce the lock using synchronized keyword. What will happen in this case? If this process is started with a myThread class 1, it will complete the myThread1 class before it enters into the myThread2 class. So when I run this one, you will see the results will be organized. As you can see them here, first we are trying to execute the myThread1 class because we are passing the value as 5. So here when I pass the value as 5 times, the I value will be 1, isn't it? So here n value is equals to 5. Then the I value will vary depends on this condition. So initially the I value is 1. So n times I, 5 times I is 1. Sorry, 5 times 1 is 5. That is the reason why 5. Then the I value will be incremented. I value will become 2. So n times I will be 10. I value will be again incremented 3, 4, 5. So we are going to print up to 25. Then the myThread1 class will be done with the execution. Then it will goes to the myThread2 class. Then it will pick the value for the n as 100. So initially n value, then in the n value for this class will be here it will be 100. So now I value will become 1, 2, 3, 4. No wonder that it has become the result like 100, 200, 300, 400, 500. I hope you have noticed, even while printing this information, there is some delay. What is that delay? Because of this process sleeping. So I want to print each process. I want each process to be executed after 400 milliseconds. That is the reason why it's taking a bit of time. As you can see them here, see there is a delay. It's not just printing at a go. It's taking some time to print this one just because of this method thread.sleep. Basically, synchronization means what is synchronization? As I said, that synchronization in Java is the capability to control the access of multiple threads to any shared resources. Basically, Java synchronization is the better option where we want to allow only one thread to access the shared resource. Right? I hope now we have understood how the thread synchronization will be done in Java. I hope you enjoyed the session. If you have got any questions, you are free to ask me through